Alright, welcome to our lesson on solving systems of equations by a method called substitution. There's 5 steps we're going to use when doing this method. And the first one is we are going to solve for one variable in at least one equation. And this step is not always necessary, so we're going to say this step is only needed if necessary. So it's only necessary when there would be 2 equations or more where at least one of them is not solved for a variable. The second step we're going to do is we're going to substitute the resulting expression into the other equation. So whatever variable we solved for in step 1, we're going to replace that variable in the other equation with that expression. The third step we're going to do is we're going to solve that new equation to get the value of the first variable, of the variable now that is common. Next, what we're going to do is substitute the value we got from step 3 into one of the original equations, and we're going to solve for the remaining variable. The final step is to write the values from steps 3 and 4 as an ordered pair. Remember, ordered pairs have an x value and a y value. And some people will say you should check that by plugging the x and the y into both equations. So let's look at what our first example is going to look like, and we're going to have 2 of them in this video. Our first example, we're going to solve the system y equals 2x and y equals x plus 5. So before we even solve that, I have a question I want to pose to you. If we were to say 2 plus 3 is equal to 5, no one would argue with that. Same if we said 4 plus 1 is equal to 5. No one would argue with that. 2 plus 3 is 5, 4 plus 1 is 5. So the question I'm wanting you to ponder, since both 2 plus 3 and 4 plus 1 equals 5, can we say 2 plus 3 is equal to 4 plus 1? And what I'm hoping you're saying to yourself is, yes, they are the same because they're both equal to 5. Well, we can use that idea with this system of equations. We have y equals 2x, and then we have y is equal to x plus 5. In this case, y is like the 5 from what we just did off on the side. So what we can do is we can just set those 2 equations equal to each other. 2x is equal to x plus 5. In fact, if you're looking at the steps that we just wrote down, we were actually able to skip step 1 and then move straight into step 2. So I'll even just write a little 2 here in gray and circle it, saying we're on step 2. Now we're going to solve this for x. So we want to get all the x terms to one side. I am going to move the x that I wrote here in red. So I'm going to subtract x on both sides. You could move the 2x, but you're going to create more steps for yourself. Anyway, on the right side, x minus x, that cancels each other out. And we're going to be left with just a 5. And on the left side, 2x minus x, that's equal to a single x. And our goal is to get one x value in this case, which we've done. So now we're going to move on to step 3, which is to substitute the number we just got in step 2 into one of the equations. And it doesn't matter which one you do. You could put it in the top one or the bottom one. You should get the same answer. I'm going to put it in the top one. So I'm going to look for y equals 2 times 5. Well, 2 times 5 is 10. So that means y is 10. We've actually finished steps 3 and 4. So 3 was when we solved. I need to correct that. 3 is when we solved. That is what we did right here when we subtracted the x. 4 is what we did when we put the 5 into one of the original equations. Step 5, we're going to write an ordered pair of an x and a y, and we found an x and a y value. In step 3, we found an x value of 5, and in step 4, a y value of 10. So our solution is 5, 10. And that wraps up example 1. I've got one more example for you to look at today. So this last example we're going to look at, example 2, we're going to solve the system y equals x plus 3 and y equals 2x plus 5. In fact, you're going to notice in this video we're dealing with fairly simple, I don't like using that word too much when we're talking about new concepts, but simpler systems when it comes to substitution, because all we're going to do, they both are equal to y. X plus 3 equals y, 2x plus 5 equals y. So we're going to just set them equal to each other. We're, in these cases, always able to skip step 1 and move straight into step 2. So we're going to go x plus 3 equals 2x plus 5. And now we're going to solve this for x. Now when I'm doing that, this time, I'm going to move the x that's on the left side. And I'm going to end up with 3 equals x plus 5. And then what I'm going to do is I'm going to move my 5 to the other side. And 3 minus 5 is negative 2. So we have just found that x is equal to negative 2. That was actually step 3 of the 5 steps we wrote down. Step 4, we take that negative 2 and we substitute it into one of the original equations. I'm going to use the top one again. So I'm going to go y equals negative 2 plus 3. Well, negative 2 plus 3, that's going to equal 1. So we've solved for y. We can move on to step 5. Step 5, we make an ordered pair with an x and a y. And we found an x with negative 2 and a y with 1. So our solution is going to be the ordered pair negative 2, comma, 1. And that's going to wrap up this lesson, this introduction to solving systems by substitution. We'll have a couple more videos coming on this idea later.